are looking at the product rule. So this is one of the methods we use in differentiation. Question now is, when do we use product rule? Let's start with this function. If y is equal to a product of u and v. So both u and v, they are both functions of x. Okay, so once you look at the first case, where you have the product of two functions. So what you do, your differential coefficient, which is called the derivative, will be equal to, you keep one constant, and then you differentiate the other function respect to the given function. Okay, plus the one you've done in the first instance, in the first case, you keep it constant and you differentiate the other functions. So it's going to be distributive in such that you keep one constant, you differentiate the other one, and then the one you have differentiated, you now keep it constant and differentiate the one you kept constant in the first instance. So that's on these aspects. We're going to look at a series of questions shortly. Let's also look at the case of three functions. If y is a functions of u, v, w, and the three functions, they are both functions of x. So each of them are both functions of x. And you want to get the differential coefficient. This is very simple. So what we are going to do is this. So derivative will be equal to, keep the first two items constant, differentiate the third one. The one you've differentiated in the first instance, you now keep it constant. It's one of the variables, maybe v, and differentiate the third variable respect to x. And finally, there is one you have not differentiated. You differentiated w and u. So we'll now differentiate v now, differentiate v, and keep u and w constants. So you can see each of the variables has been differentiated once. Okay, and that's that for the three functions. Okay, w is differentiated in the first case, u is differentiated in the second case, and v is differentiated in the third case. Okay, two functions will be kept constants in each of those cases. So that's that on these aspects. The next thing we want to look into is to look at questions. We have the following question here: differentiate with respect to x. We have the first one, we have the second one, we have the third one, we have the fourth one, and we have the fifth one. If you are watching me for the first time, please subscribe to the channel so that you can keep track of the updates of this channel. Don't stop there. Give the videos a likes and begin to share the links of this video across your social media platform. Thank you for doing that. Take your journal and begin to follow along with me. So let's look at the first solution. So this is the first one we have, which we are giving it a name, but it's not a must. If you like, also we can just write ddx of the function. I'm going to stick with this one, called the expression y. So in this case now, my according to the product rule, the first one is my u, which is the functions of x. Okay, x cubed plus 1. Get the derivative of that, the 3x squared. The second one, which is a v as the functions of x. Let's get the derivative of that one, which is equal to what? The 4 will go to the front, and then the function, the power of the functions minus 1. The derivative of a constant is 0. So that's what we have. So we can quickly get the differential coefficient, and that will be equal to, don't forget the formula we gave you, that you keep the first one constant, then you differentiate the second one, okay, then plus the one you are differentiating here, you keep it constant, okay, and then you differentiate the other functions. So let's make substitutions to this equation. My u is x cubed plus 1. The derivative of v is 4x cubed plus v is x to the power 4 plus 1 times the derivative of u, that's 3x squared. Then you can do the expansion, and that will give you 4x cubed times s cubed as 4x to the power 6 plus 4x cubed times 1, that's 4x cubed, and then plus 3x squared times x to the power 4, that's 3x6, and then plus 3x squared times 1, that's 3x squared. So then you can do the addable, those functions that you can add together, those ones that have the same exponent, the same power. So we have 1 here, this is 4 here, this is 3 here. So that is 7 x to the power 6 plus 4 x cubed, and then plus 3 s squared. So that's that on that case. If you have your comment, please put it in the comment section. If you have a you can as well do the expansion for this one. Do the expansion, the differentiation, divide the x, and that will be equal to 7x to the power 6 plus 3x squared plus 4x to the power 3. The derivative of 1 is 0. So that's that. Question 2, we have this. We can call it y. Let's y be equal to. We can open the brackets, and that will be y equal to x1 minus sinx cosx. Then after that, we can get the differential coefficient. You can see this one is 2i10, the product of 2i10. So we can call this one u. We can call the cosx v. So the derivative, the y, the x will be equal to derivative of sine is cosx, then minus. I'm going to open a bracket now, okay, and I'll use product rule for sinx and cosx. So I'm going to keep the first one constants. I'm going to differentiate the second one. Okay, I'm using prime for my differentiation. I'm using this one, cosx times sinx, derivative of okay. And if you want to use the prime I put on it, you can use ddx. So this could be written as this prime. Yeah, the same thing. If you want to use the prime, you can use ddx. Okay, which means derivative. So this will be equal to cosx minus derivative of cos is minus sine. So that will be minus sine times sin x. So that's minus sin²x plus derivative of sin x is cos x. So cos x times cos x. That's cos²x. If we like, we can do the brackets. That could be this way, or we can make the answer to be in this form. The y dx, which is same thing as a y prime, as a function of x. We can do it this way. That will be cos x minus, open your brackets. We can write the cos²x first. So that's our cos²x. Okay, that one is positive, then minus what? sin²x. Okay, and that will give us for the final answer cosx. This bracket is an identity. This is an identity. Cos²x minus sin²x, that is equal to cos²x. And that's that on that. The two answers are correct. And last thing I want to chip in is that we expanded this expression. It's not compulsory that you expand. You can make this one, the first one here, as your u, and you can make this one as your v. The choice is yours. Okay, it's not compulsory that you should. This is the third one. We are trying to differentiate respect to x. Okay, let's see the solution to that. So we can write this one as the derivative, which is ddx of the function. Let's expand these brackets. So that will be equal to 3x squared plus 4x cosx. If you do the expansion. So the meaning of this is going to be ddx of the first item. Okay, open the brackets, and then plus ddx of the second expression. But the second expression is a product of two items. This is the u as a function of x, and this one here, cos x, will be what? Will be v as a function of x. So if you differentiate the first one, this one here, the power will multiply the constants. That will be 6, and then the power minus 1, that's 6x. And this one, this second part, take the first one as a constant and differentiate cosx. Differentiate, that will be ddx over cosx. Okay, then plus. Now keep cosx constant and differentiate 4x. So this will be equal to, if you differentiate cosine, it will be minus sin x. So and that will be minus 4x sin x, then plus. Don't forget the one we have here, 6x. Then if you differentiate 4x, okay, and that will be equal to 4 cos x. That's what you get. Try that. That's what you get. And put the answer in the comment section for the fourth one. Put the answer in the comment section for the fourth one. Okay. Put the answer in the comment section. So that will take me to question 5. So this is question 5. We are told to differentiate respect to x. So what we do in this case is to give this expression a letter. Let's call it y. Okay. So in that case now, in this case we have a product of 3 items. So the first one, you can call it u. That's the first one. The second one, you can call it v. And the third one, you can call it w. So what we do, this is a product rule for 3 items. What we do in this case is very simple. And we can apply the formula. I'm going to do it this way. My differential coefficients divided x will be equal to what? I'm going to take the first item constant. That's 8x squared times 1 plus sin x. Take that one constant and differentiate the third one. Then plus the second one. Don't forget, we are differentiating this one. You can only differentiate this one 1. You now keep it constant. Differentiate 8x squared times 1 plus cos x, and then times derivative of now differentiate the second one here. That's times 1 plus sin x. Okay. Then finally plus. There is one you have not done now. You have not differentiated at all 8x squared. So we are going to this one will be kept as a constant. The second and the third one kept as a constant, and they will now differentiate 8x squared. So you can use prime for that. So you can see that differentiated in each, it's going to be 3 segments, but in each part, must ensure that different functions are differentiated. In the first case, we differentiated w. In the first case, in the second case, we differentiated v, while the remaining part is kept as a constant. And in the third case, we differentiated 8x squared, while the v and w are kept as a constant. Okay, let's quickly go get the expression. So for the first case, if you differentiate 1 plus cos x, the 1 is a constant, so it's going to give you 0. So we're going to have minus sin x. Then plus the second one, 8x squared times 1 plus cos x. Differentiate 1 plus sin x. This will be cos x. That's cos x. Then plus the third segment. Derivative of 8x squared. That's 16x. That's 16x. 2 times 8. That's 16. And then the power minus 1. So times 1 plus sin x. 1 plus cos x. Okay. This one times 8x squared. So we're going to have minus 8x squared sin x times 1 plus sin x, 1 plus sin x, okay, and then plus the second one, that will be 8x squared cos x times 1 plus cos x. The third one, 16x times 1 plus this one, 1 plus cosx. We're going to do something here. We're going to, this one, 8x is here. You can expand this one, and that will be equal to sinx plus sin²x. Okay, close the bracket. Then do the same thing also for the second one. 8x squared cos x times 1 as cos x, and then plus what? Plus cos²x.